All right. Yeah, let's start. So I'm going to talk about data-driven Elasticsearch architecture, and I'm actually not going to explain the title just yet because it's part of the presentation. Yeah, before we start, maybe a quick word about me. So my name is Alexis. I'm a custom architect. The rest is just title sugar. Basically, I help customers just address any kind of use case, any kind of problem they have with Elastic at scale. Yeah, you have some of my social and my community Slack if you want to hit me up on the community Slack. Yeah, feel free to do so. All right, so let's go a bit into that title, the data-driven Elasticsearch architecture and what it means. So obviously you've all used Elasticsearch here before, and you probably know you can do a lot of different things with Elasticsearch. You can do GPS stuff. We're going to talk about that in roughly 30 minutes. You can do search, any kind of search. You can do observability. You can do security. A lot of different use cases. And obviously, because you do all of these different things, there's a lot of different approach you can have to building your cluster, to building your use case. And a comparison I like to take, or rather a question that you typically have when you work with Elastic, or rather an answer actually, is it depends. You probably have plenty of people on Discuss, on any kind of social, or even if you work with us before, you've heard people say it depends. It's actually in our source code, so the values of the company, so to speak. Ultimately, you can do so many different things with Elastic that there's not a single solution, not a single way to achieving what you want to do. A comparison you can take is kind of like buying a car. If you go to the mechanics or any kind of car shop and go like, hey, I would like a car, sure, they can give you a super fast car. They can give you a F1 car. But then if you tell the mechanic or the sales guy, well, I actually want my car to go in the desert, probably the F1 car is not the best car for the job. And that kind of touches our topic here, the data-driven Elasticsearch architecture. It's about choosing the right car. It's about, okay, what information can I gather on my cluster itself, on my Elasticsearch, to be able to understand whether the car is actually the right one for the job. So if you would do it with a car or any kind of purchase, why don't you do it with your cluster? Ultimately, that's the first question. And you might have answers like, well, we can't measure what we're doing. We don't really know if the car is going in the desert. We can't look outside the window. We don't know what we need. Well, do I actually need to go in the desert? What kind of data, what kind of metric, what kind of API can I use inside of Elastic to actually answer that question? And the final one, and it's always a topic, changing is complicated. I will actually not touch so much on that one. How do you address change? It might be a future meetup, so to speak, but yeah. Second problem statement, and I'm again going to take an example, which is, well, let's assume you go on vacation, you go to the mountain, and you start packing your bag. And since you're going skiing, let's say you're going to pack your skis. Obviously, you're going to pack your goggles because you have not such a good weather like this weekend. If you've been skiing, you're going to pack your boots. Let's assume these are ski boots. I didn't find the right picture, but you get the idea. And you're going to pack your snorkel and your flip-flops. Okay, but doesn't really sound right here. You probably know exactly where I'm going here. If you don't do it with your luggage going in vacation, why do you do it with your data? And that comes, again, from real life experience, working with customers, noticing that actually a lot of the things they store is not things they, one, actually need, and two, actually use. And again, we come down to the same questions. We don't know what we use. Well, guess what? In just a second, I will show you that Elasticsearch can literally tell you, hey, you use that part of the data. Well, guess what? You can actually tune, optimize, with quotes there, the way the data is within your cluster to make sure you actually fulfill exactly, precisely your use case. We don't know what we need. Second question here. Again, like that's kind of, that's a question we will be able to answer, or you will be able to answer after that presentation. Final question, same here. Changing is complicated. So ultimately, these two questions, they lead to one thing. And at scale, obviously, depending on the scale of your cluster, that might not be a waste. But I do work quite a lot with customers that might ingest terabytes of data per day. Ultimately, if you notice that 10, 20% of the data you have in there is not actually used, well, guess what? That's a lot of waste here. And we can look at it from a pure waste perspective, but we can also look at it from a performance perspective. If you have a lot of things that is actually unused, well, that's kind of like a bag where half of your bag is used for things you don't actually need. Guess what? The bag is heavy, and you still have to carry it. So probably not that good of a performance. Ultimately, you'll see the goal here is to kind of bridge the gap you might have between the admins, the people who might be you actually, who built the Elasticsearch cluster, and the people who use the Elasticsearch cluster. That's where our concept of architecture comes in. It's about designing a cluster or a system here exactly in the way you aim to use it, basically. And so that's the concept here. With Elasticsearch, that can mean a lot of different things. If I were to break it down in two different categories, you would have on one end what it's not really physical, but you get the idea. What I would describe as the physical architecture. So I have nodes in a cluster, different count of nodes. They have different characteristics, count of CPUs, RAM, all these kind of things. And these, depending again how you run the cluster, are things you might not be able to change. Guess what? The servers have been purchased, they're already there, and you want to maximize the use. The second part, which is actually a bit more interesting for us, is again what I call the logical architecture, which relates to the way the data is within your cluster. Getting slightly technical, not too deep, we talk about shards here. That's the way you basically break your data down, and then these things can be logically put together in what we call indices. Anyways, so these things have also characteristics you can change: the count of shards, the size of the given shards, the mapping, and the settings. Ultimately, the way the data is within your cluster. And that's the part I'm specifically going to work on, because these are the things we will be able to measure in terms of what the performance is, what is actually being used within my shard, and then something I can actually change as aligned to my use case. So there's a lot of things here. And first reaction might be like, hey, what thing should I change? Because if you've worked for some time with Elastic, you know that just touching what button can actually completely break your cluster, go to the red state, and make it completely unusable. So ultimately, we want to be able to know what is the data part, what is the things that will help me guide my decision in a way that, one, I'm not going to break my cluster. Two, I know I'm making the right decision. And three, I know what the impact of my decision will be. So before talking about data-driven, the data that we will be gathering, I want to take a step back and maybe start talking about what we do with the cluster. And if we look at actually any kind of cluster, what you do with a cluster is one of three things. You ingest data, and actually, like in a lot of cases, you're doing the three things together as the data flows through it. So you're doing three things. You're ingesting the data. That could be, gathering the data somewhere, maybe transforming it, maybe enriching it with some additional pieces of information. Second, you're searching the data. Obviously, you want to get some insights from what you ingested. So you perform queries, you perform aggregations, you have some nice dashboards in Kibana. And the third thing is archiving the data. Well, you might need to keep the data for regulatory purposes for something like a year. The data has to be there. So for taking a slight tangent here, typically people talk about these hot tier, warm tier, cold tier, frozen tier, which are the correspond to the ILM phases and the nodes you can actually provision if you use our cloud offering. I don't really like people talking about these things because you lose the idea of what you want to do with a cluster, which is, again, these three things: ingest the data, search the data, or archive the data. And from a user perspective, if I were to actually use my cluster, I'm not saying I'm ingesting the data. I'm searching the data, nor do I say I want a hot tier, I want a warm tier. What I say is I do one of these things you have here at the bottom, which are the actual things that I might be performing. Well, I'm performing interactive search, as in I have some requirements to have a fast response, or times insensitive search. I'm just starting something, I'm coming back 5-10 minutes later after my coffee, and I do get the results. So by understanding what is the goal, why am I creating ultimately an Elasticsearch cluster, I'm able to unravel the entire use case and start that conversation about data-driven architecture. So the what do I aim to do is the centerpiece here, is understanding what is the goal of my cluster. And based on that understanding of the goal, I'm then able to ask a couple other questions, and that's where we start. We're going to start talking about data. We're going to become a bit more technical here and talk about the tools that Elastic offers to actually measure the resources usage of my cluster, assess what is actually using the resources of my cluster, and checking what I can alter. Ultimately, it can lead to better performance. It can lead to money saving, reducing the size of the cluster to achieve the same results, all these kind of things. So let's maybe get into a practical example. Let's say we have a cluster, we have a bunch of nodes there, and I want to assess, let me go back one slide. I want to answer these three questions. First one, do I use my resources in my cluster? Does it actually make sense to have 5, 10, 15 nodes? Could I do theoretically the same thing using fewer nodes? Second question, you have it, what uses my resources? We'll see a different API, some different APIs that allow me to do that. And finally, you'll see that third bit, at the bottom is kind of melded into the others. What are the actions I, as an admin, can take to actually optimize my use case? So let's go back to the practical example. Let's say we have a cluster that is available here. And by the way, I'm directly showcasing the results here. At the end, I'll put on the screen 2 QR codes that's linked to a Jupyter notebook that perform this analysis. So I've on purpose focused on the result and the approach. If you want to actually get very technical and read the code that leverages the API calls and gets you to such a result, there's something at the end. So the first API I'm going to talk about is the node stats. You have a bunch of nodes in your cluster, and you can simply ask Elasticsearch, hey, I want to get info about what kind of workload I run there and how things are going. Namely, the part I'm going to be interested here in is the indexing time and the search time. You can ask your Elasticsearch cluster, hey, across all the members of my cluster, how long did they spend indexing data? How long did they spend searching data? And that's where it gets interesting, because remember my question, do I use my resources? I can actually get a precise measure of how much I use my resources, which is how much time did I spend actually indexing data? Remember my 3 objectives, the first one being ingesting. How much time did I spend searching the data? Again, second use case, second high-level use case, searching the data. So you have some results here on the right side, performing that analysis. So basically getting that JSON response you have here, crunching it across all the nodes in my cluster, and making a nice table off of it, and basically analyzing the result. So some information here, but what's interesting, and by the way, that's a real cluster that comes from our own SRE platform. So we do have quite a large cloud footprint, as you can imagine. And that data you have here comes from one of our cluster that monitors our cloud platform, basically. So what's interesting here is I'm going to focus on the last 2 columns. So the write load and the read load normed. More info about that in the Python code. I will be showcasing at the end if you want to have a look. But what's interesting is if we actually look at the read load here, we notice that our hot tier that might correspond to where we want to have fast response doesn't actually have that higher of a load compared to our frozen tier, which might correspond to our archive tier. So as an admin or as someone who wants to use the data to actually challenge the way the cluster is built, well, I might wonder whether it might make sense to introduce an intermediate tier, which will be less expensive than my hot tier, to actually handle the search, because there is no increase in terms of load or higher load on my hot tier compared to my frozen tier. So that's the kind of insights I can get. Again, bird's eye view, just looking at the nodes in my cluster. Do I use my resources? Apparently here on the hot tier, so on the first half of my cluster, I would say that no, I'm not actually using the resources, and I might go to my boss and challenge that part. For the record, actually, I said that's our SRE platform. The entire analysis I'm presenting now is actually something we're currently doing internally within our own estate. And the last figure, so last I checked, we're able to reduce our footprint of, so I don't have the exact percent, but 600 nodes in our entire footprint worldwide was able to be removed because we were not using them. And we were able to surface that using exactly that approach, basically. So you might tell me, okay, that's great, Alexis, but that's on the node level, that's super high level. And actually, you said in the first part that the physical, what I call the physical architecture, is not really the part of focus. And that's true, actually, because we can actually dig down to one level deeper. And that's the part that's probably most going to interest you, which is getting the same statistics, but on the index level. So you're able to look at your entire cluster, look at every single index, and get precisely how much time did you spend searching each individual index. And that's super interesting here because you're able to compare, let's assume you have, I don't know, 20 different sources of data coming in your cluster. You're able to actually compare them and go have a result that is a table on the right side or something. Actually, no, it's in 2 slides. So you're able to have a table that is something like this and compare whether something that you actually store is something you actually search. I do have, I don't know, terabytes of data in there. Do I actually search that terabyte of data, 4 terabytes or something, 4.8 terabyte of data I have here? Do I actually search it? If the answer is no, again, going back to my 3 use cases, 1, why do I ingest it if I'm not searching it? And if I really need to ingest it, maybe I just need to archive it. Maybe I just want it to be there for compliance purposes, and that's it. So again, using the data here, asking the right question to our business users to identify whether I'm actually fulfilling my use case. Going one step further, if I would graph that data, you're able to surface that exact use case. What you have here is, so it's a bit small, you can't really read it, but on the top is my on-disk footprint for that specific cluster. At the bottom is how much time do I spend searching the top data. And the interesting bit is, well, you can actually spot it, is you have that orange slice right here, which is stored but not searched. So the question directly is, well, why am I not archiving it? The footprint of that thing, I don't have it in mind. Actually, it's probably like 200 or 500 gigabyte here. If I'm able to move it to the archive tier directly, well, that means I can maybe remove 1, 2 nodes in my cluster and therefore save money. That also means I have, more space for the existing data. I can also improve performance, all these kind of things. Last thing I can do with that data, and that one is quite interesting, is actually derive my ILM policy. So the way the data decays over time in your cluster, the way the data flows, your 3 use cases, the ingest, the search, and the archive use case, based on how much I query it. So what you have here on the x-axis is how old the data is, and the y-axis is how much I search it. And what's interesting here is you can actually somewhat identify 3 patterns. You have the super high load initial usage of the data. Well, that could correspond to your ingest here. You have the middle part where you still have some variable load in terms of search. That would be your search use case where you have that kind of analytical usage. And the third part, sorry, is the archive tier where you see that flat usage. Yes.
What are the axes?
Sorry, x-axis is how old the data is.
Sorry, yeah.
So the question was, what are the axes? The x-axis, so the bottom axis, is how old the data is. So if the more you go right, the older the data is. Let's imagine you have data that's flowing through the cluster. If it's on the right side, I think at the very right, it's 1 month. No, it's 2 months old. And the y-axis is how much you query the data. What is the querying time? How much time do I spend querying my data? And that's the cluster reporting that information. So how much ultimately did my user spend querying the data? And as you can see, you have these 3 different patterns that will allow me to say, hey, I want that part to correspond to my ingest, that part to correspond to my search, and that final part to my archive. And in turn, having that information allows me to define the size of my cluster, how many nodes I have in there, what my ILM policy should look like, all of these things together. Final thing I want to talk about is, digging even deeper. You have the index, okay, great. I know how much a given index A is being used, is being searched compared to index B. But what about going deeper? I have, super large index with dozens, hundreds of fields in there. Does it actually make sense? If you actually, look at your mapping, so the way the data is structured, you get a list of all the fields that you can actually search, that you can actually aggregate. There's another API which is interesting, which is the field usage stats. That's the middle part you have here on screen, which basically asks Elasticsearch to tell you how much each of the field has been used. And staying high level, you could simply say, hey, if a field is not used, I want to cut it out. But going even deeper, Elasticsearch tells you how much each of the data structure within a field is being used. I don't want to go too deep here, but basically Elasticsearch, when you index some information inside, creates different data structures that in turn are used for different purposes. For instance, what you have on screen is two things, the inverted index and the doc values. Let's keep it simple. The inverted index is used when you perform a query on a given field. The doc values is used when you perform an aggregation, among other things. So if I look at my fields here, I, for instance, noticed that my bar field, so that's the one that you have in the middle, does not have any use of my inverted index. With that in mind, what I could do theoretically is say, well, if no one is actually querying the data, why am I creating the data structure in the first place that enables me to query the data? I could simply, and that's what you have on the right side, deactivate it. Another example is if my foo field is simply not used, I do not have that field in the field usage stats, I could simply remove that field altogether. And again, you might ask, why would I do that? Well, for say space saving purposes, remember my piece of luggage, I don't want to put my flip-flops in there. If I don't use my flip-flops, if I know I'm not using my flip-flops, and I do know I'm not using my flip-flops, there's no point in taking my flip-flops. Okay, great. I removed a bunch of things, but what's the benefits? And there's actually another API that's probably one of my favorite API. That's a very nerdy thing to say. But the super nice API is something called the Analyze Index Disk Usage API. It's a very long name. But basically asks Elasticsearch to look at a given index and tell you how much each of the field is consuming on disk. And you have here, again, an example of result where on a given index, it's able to tell you, well, guess what? The full field that you want to cut is like 271 megabytes on disk. So again, if you extrapolate on your entire cluster, removing that field allows you to save 271 megabyte times the amount of indices you have. Due to my previous analysis, if I'm able to remove all the parts I'm not using, if I'm able to remove the flip-flops, remove the snorkel from my piece of luggage, maybe I can take a smaller piece of luggage. Maybe I can fulfill the same use case with a smaller cluster. Maybe I can have better performance with the existing things I have. So these are all the things we can use to, again, be data-driven, identify what the usage is on my cluster, and then in turn, alter some of the things I have in my cluster to achieve either the same thing at a lower cost or have better performance with the existing cluster. Some key takeaways. The approach here is the most important thing. Understand what the use case is, understand the usage pattern. There's, again, some APIs, a lot of APIs you can actually use that give you direct access to the data. It's only up to you to actually consume these APIs, understand what the usage patterns are, and then changing the way the cluster is architectured. Second key takeaway, and I work a lot with, I push that information or that messaging a lot to customers, is I summarized it by saying measure twice, cut twice. It relates to the fact that this exercise is an ever-going exercise, in the sense that the use cases you have now will not be the same as the one you have in a year, 2 years. So by making sure you actually have the measuring tools in place to constantly track these metrics will allow you to see whether these use cases change over time and therefore change your architecture. The things you can use, the monitoring indices, because all the data, most of the data I showed here is actually out of the box available in the built-in monitoring indices. Otherwise, the stats API, these are the things that will directly allow you to have that. And final thing is actually coming soon. Elastic has acquired a company called Obster. You might have heard of it. And a lot of the capabilities that I've demonstrated here will be built in Obster in the near future. So we don't have a timeline yet, but that's something that we want to keep track of. Final thing, and that will be my closing statement here, make sure you align cost and value. Do you use what you store? And if you don't use it, why do you store it? Maybe you can cut it out based on the data that you have. As I said earlier, so if you want to actually have the code that allows you to perform that analysis, you can scan these two QR codes. My mom always told me not to scan the QR codes of a stranger, but these are pretty safe. I tested them. They should, lead you to get to a GIST in both cases. And there's a description at the top. You can basically just put a JSON file, and I explain how to generate it and start your own analysis with your own cluster, basically. So that's my last slide. I mean, I have one more slide, which is questions, question mark. So, do you have any question? Yeah.
I have some swag for good questions.
Okay, thank you for your talk, really informative. And I have a question is about which luggage version is this referring to, version 7 of Elasticsearch or version 8?
Good question. So if let's go back through the API. So that one, the Disk Use Edge API, we need to check. So so that's just because I screenshots. It's not 8.13. I'm wondering whether it's already there in 7.17.
Sure it is.
Yeah, I think it's quite old.
It's pretty old.
Like I would say 7, maybe 13, 7.10, something like that. Anyway, if you're on 7, you should be on 7.17 because anything older than that is not maintained anymore. So I think it's there on 7.17. All the others, so the field stats API, pretty sure it's there. It was released at the same time as the Disk Use Edge API, and the index. There we go here. The index stats API and node stats API, that would be the previous slide. These are super old. I'm going to go like with maybe version 6 or even version 5. Okay, well, you have the answer. So super old, you have access to these metrics.
And the follow-up question is about, have you ever thought about providing a Kibana dashboard for that?
So we do actually have, that's not really nice what I'm going to say. So we have a private repo that actually has like a script and some dashboard that exactly do that analysis on an existing cluster. I'm kind of fighting internally within Elastic to open the repo and give these tools. There's some politics involved. Long story short, yes, we do have the tool. I do not have the right to open it currently. So I'm mostly focusing on the approach. Yes.
Microphone on the top. Is this it? I don't know which side's the top.
Yeah, works.
Yeah. Okay. Yeah. Okay. So my question is, this seems a little bit complicated. Is intelligent tiering coming and like automatically consume this and rebalance the nodes and what the indexes are utilizing? I mean, because I can also imagine the challenge the other way though, that you don't want to necessarily be messing with the way the customer has organized it, or if you're running the open source version, et cetera. Any thoughts about that?
Yeah, exactly. Well, that would have been my answer. So that's serverless that we have coming up. I think when is the beta opening? I think it's like
May.
in the next 2 months, or May. Okay, that's what I had in mind. So about basically what you're saying here is you want something that's easy. You can just throw data inside and have automatically all these things happening. And the answer is serverless indeed. So where you can just throw data and it kind of comes up with, it's not as complicated as that. It doesn't do hot, warm, cold, frozen, whatever, but it's able to, put data in the right place as aligned to how you use it, basically.
First of all, thank you. Let's say that I don't have anything better to do after this meetup. I go home,
Yeah.
log into my Elasticsearch cluster. What would you recommend me to do following your talk? As like the first two things I should go and try on to improve my,
So the
my
first one,
usage.
again, I mean, I'm going to go back like one more slide, two more slides, actually that one. So the first bit, and that which is a bit hard to say, is asking that question. The first thing I'm going to answer is, well, it depends. And, you're probably going to insult me at that point because I'm kind of repeating my presentation. But the first thing I want to capture here is what you want to do with your cluster. If the goal is, hey, I want to get better performance off of it, or if I want to reduce the cost, or I want to onboard more data and not grow my cluster, you're going to approach the problem in a different manner. But let's assume, you just have a cluster, you want to make sure, hey, is it, properly built, basically. The first, again, two things you're going to assess is, do I use my resources? That's my top left. Okay, you look at your nodes, you look at the analysis I did here, and that's the first on the two GIST I put on screen. That the first one, you'll be able to assess whether you actually use the resources. And the second one is, well, let's say I use my resources. Let's actually look inside. Let's look at the data. Let's actually make sure that the data I have in there actually makes sense. And that's the second part. That's the second GIST, where you would actually assess whether all of the indices that you have there, all of the data that you store, is actually something that you use in your dashboards, in your analytics, and so on and so forth.
Thank you.
Problem, yeah.
Does this framework also include shard analysis? Because my experience with most customers that their performance problems almost always related to the fact that they've got too many small shards.
So you want to have in the two GIST, you wouldn't have anything that relate to shards. The reason being that it would be more, from my perspective, I would see an analysis like that one more, fit for something like ES Rally. So you would benchmark whether it actually makes sense, where I chose to focus on something that doesn't require bringing additional external tool. Basically, the analysis you have here, it's just something you get from the JSON that's in the cluster, and that's it.
I mean, but you could do a breakdown of all the shards and how big. Like if they've got like 1,000 shards and 900 of them are less than 1 gigabyte, they have a problem.
Yeah, for sure. Like, very valid point. It's not something I cover in the presentation.